So before we get on to some more operations with algebraic fractions, so before we move on to multiplication and division, we're just going to take a little detour to talk about simplifying algebraic fractions. Because if we can conceptually understand this and really get our heads around it, it makes our quite difficult questions, which we'll be doing later in terms of multiplying and dividing algebraic fractions, it'll make them a lot easier. So we're going to do this little video here just to give you a an understanding of how we can simplify these, because algebraic fractions work in a very similar way to regular fractions in terms of simplifying. So let's revisit the regular fraction. So I'm going to give you a fraction of 3. Whoa, that's a shocking 2. 3/12. And I want you to simplify it. So what we did in our previous videos ages back, which you can look or you can look at the playlist for year 7 fractions. But we said, well, to simplify this and to find an equivalent fraction in its simplest form, we just took whatever common factors our numerator and our denominator had. So here we had 3 as a common factor. So we essentially divided top and bottom by 3, and we would wind up with 1/4. So that is, in essence, what we do when we simplify fractions. I won't go too far into it. If you need some more context, feel free to check out my previous video. But now we're going to move on to see how this is affected by algebraic terms. And the important thing to note here is that an algebraic term, so some unknown of x, y, z, a, b, c, whatever, this just represents some number, some unknown number. And algebra follows all of the same mathematical processes as regular arithmetic. It's deeply linked to what we know about arithmetic of our regular numbers. Now, let's see how this changes here. Well, we have 3 multiplying by some number of x on the top. Now, it's important to know we don't know what x is, but we have 3 and a 12 on the bottom and just this x term here. Now, our 3 is multiplying by the x, and if we were to find a common factor here, well, all we know is that 3 will go into 3x x times, because 3 lots of x is 3x, and 3 goes into 12 4 times, like we discussed earlier. So we can divide top and bottom once again by 3. Now let's see here what we'll get left with. Well, we will have just x on the top, because when you divide 3 lots of x by 3, you will get x. And on the bottom, we will have 4. So the actual procedure doesn't really change. We're still finding factors and the highest common factors between numerator and denominator. And 3 is the highest one we can find because we don't know what x is. You know, if x was 2, for example, then we get 3 times 2 and we get 6 on the top. So cool, we have a highest common factor of 6 top and bottom, but we don't know what this is. So we can't touch it anymore here. Now, let's look at another example. So we'll go this example where we're going to see what happens when we have 12 multiplied by some unknown x over 6 lots of x. What are our common factors here? Well, let's start with the ones we can kick off right off the bat. So in terms of our real regular known numbers, we have a 6 here and we have a 12. Now, 6 goes into 12 two times. So we have a common factor here of 6. Now, so I can write the top. I should do this. We can divide top and bottom by 6. And we will get, well, 2 lots of x on top of, when we divide 6x by 6, we get, well, 1 lot of x. But, all right, we're in a pretty good position here. But what do these actually mean? Well, algebraically, these can be any number, right? But the fact that we're using the same term to represent these, this means that this number, whatever it is the same as this number. If this was a y, for example, well, that just represents some other number. So we can't do anything more. If this was, any other pronumeral, by pronumeral, I just mean any letter representing some number. If this was any other pronumeral other than x, then yeah, this is as far as we can get. But we have a common denominator of x on top and bottom. It doesn't matter that we know it or not. We just know it's the same number. So we can divide the numerator here by x, and we can divide the denominator by x. So we'll get left with, 2 on the numerator and 1 on the denominator. And any number divided by itself, divided by 1, just gives us that number. So we can write this as 2. So the process doesn't change too much, but we just know that all we're doing is finding common factors top and bottom. And here we had 2 common factors. Well, we had 6, to use my laser pointer, we had 6 in these numbers, but we also had a common factor of x top and bottom. So that can be simplified as well. Why? Because x can be any number, but they are the same number. So 2 multiplied by any number divided by that same random number can be simplified. Like if I was to give, let's just do a little side thing here. If I had 2 lots of 3 divided by 3, well, 3 is just a common factor here. It's the same number. So I could divide top and bottom by 3. Because 2 is multiplying by 3, and here it's like saying 1 lot of 3, because we just have a 3. And once again, we would get 2 over 1, which equals 2. It works the same way, guys. So let's try one more example here. And then we will wrap up for this, but I'll try to include progressively more different examples as we go through these types of calculations with multiplying and dividing algebraic fractions. So, okay, let's try this one. I'm trying to do little baby steps to ease you guys into this idea. So we have 10x divided by 12x, y. Now, I've deliberately color-coded these, if you can tell. I'm just grouping the numbers that we can think about that we can think of as common factors for numerator and denominator. So I'll try to do this a little bit quicker. We'll just try to do this all together. Well, we have an x and an x here. So we already know that's a common factor. And the highest common factor between these numbers is 2. So we can say that, let me use a different color. We can say that 2x, 2 lots of x is a common factor here. And let me show you why. So this is like saying 2 lots of x times, well, what number would that multiply by to give us 10x? Well, that will multiply by 5. And on the bottom, we have 2x lots of 6 multiplied by y. So these two numbers here are clearly common factors. So we can factor them out. Or we can just divide by both of these top and bottom just to get rid of them because they're a common factor. And in the end, we're trying to simplify. We're trying to get an equivalent fraction to this in its simplest form. So dividing top and bottom by 2x, well, we're going to get, like we saw here, so these will effectively cancel out because this is like saying 2x over 2x multiplied by 5 over 6y. And 2x over 2x is just 1. Because no matter what the x's are, any number divided by the same number just gives us 1. So in essence, we're just saying, well, we're saying 1 lot of 5 over 6. Staying true to my color coding, my y will be purple here. So we've simplified this. And because 1's just multiplying by this number, well, that's just going to be this number, right? So we'll get 5 over 6 y. Now, let's pause for a minute. Do we have any more common factors top and bottom here? Well, there's no common factor between 5 and 6, so we can't do anything with that. And we have a y on the bottom. Doesn't matter what y is, it's any number being multiplied by 6, but we don't have it on the numerator. So there's no common factors with our y either. We can't do this nice trick that we did up here because we don't have a common factor on the numerator and on the denominator. So these were just a few examples of how we can go about simplifying algebraic fractions. And I'll ease you guys into using this strategy when we begin to simplify multiplication and division of algebraic fractions. I'll see you guys next time.